Okay. Now we are going to start uh, 11th scenario of katakoda docker practical series. The 11th one is manage container log files. I'm going to start the scenario. This scenario will explore the different ways you can handle logging output from your application and services when running as containers. The first step is Docker logs. When you start a container, Docker will track the standard and standard error outputs from the process and make them available via client. Example, in the background there is an instance of Redis running with the name Redis server. Using the Docker client, we can access the standard out and standard error outputs using this command. Docker logs Redis server. Continue. The second step is syslog. By default, the Docker logs are outputting using the JSON file. Logger means the output stored JSON file on the host. This can result in the disk. As a result, you can change the log to a different destination. Now try will write all containers logs to the central system. Most system widely used standard for message logging with parameters separation of the software that generates messages, the system that stores them, and the software that reports and analyzes Wikipedia. Syslog drive is designed to be used when syslog is being collected and aggregated by external system. The command below will This command below will redirect Redis logs to syslog. If you attempted to view the logs using the client, you will see the error. Logs command is supported only for JSON file. Let me try. Hmm. The third step is disable logging. The third option is to be disable logging on the container. This is particularly useful for containers which are very they are logging. Which config? The inspect command. Configuration for particular container. The command below will output the log config section for each of the containers. Docker inspect. This scenario explored how you can access the log file from containers and how you can change where they log to. In future scenarios, we'll explore how you can use external logging services to aggregate all the logs. Then now we move into a next scenario. That's our 12th one. That is ensuring container uptime with restart policies. To start it. I'm going to start this scenario here. Uh, Docker ensuring uptime. Historical is in the previous scenario we have launched some containers, but like any process, containers can crash. This scenario will explore how you can keep containers live and automatically restarted them if the crash unexpectedly. Going to start scenario. The first step is stop on fail. Docker considers any containers to exit with non-zero exit code to have crashed by default. Crashed container will remain stopped. So we have created a special container which outputs a message and then exits with code 1 to simulate a crash. You can launch an instance using this command. This If you list all the containers including stopped, you will see the container has crashed. You will see which the logs will output a message which in real life would helpful indicate information to help us diagnose this issue. Docker log restart default. Uh, the second step is restart on fail. Depending on scenario, restarting a failed process might correct the problem. Docker can automatically retry to launch the Docker a specific number of times before it stops trying. Example, the operation allows you to say how many times Docker should try again. In the example below, Docker will restart the container 3 times before starting. Mm, as you can see from the logs, it was launched on 3 occasions. Mm, always restart. Finally, Docker can always restart a failed container. Uh, in this case, Docker will keep trying until the container it is explicitly told to stop. Use the always flag to automatically restart the container when this crashes. For example, I still in use of always. You can view the restart attempting via the log by this command. We'll try it. Hmm, this scenario has introduced how you can keep alive containers even after they crash. Then we are moving to our next scenario. That is adding Docker metadata and label. In here, when running the containers in production, it can be helpful. It can be useful to add additional metadata relating to the container to help their management. This metadata could be related to which version of the code is running, which applications or users on the container define special criteria, such as which servers they should run on. This additional data is managed via Docker labels. Labels allow you to define custom metadata about containers or image which can later be inspected or used as a part of a filter. This scenario guides you through creating and querying the metadata for containers and images. Here we can see recommended guidelines. There are recommended guidelines to allow in working with labels to ensure they are consistent and manageable as defined by Docker. Firstly, all tools should prefix their keys with the reverse DNS notation of domain controlled by author. For example, com katakoda dot some label. Secondly, if you are creating labels for CLI they use use then they should follows the DNS notation, making it easier for users to type. Finally, a key should only consist of lowercase alphanumerical characters, hashes. Now I'm going to start this scenario. The first step is Docker containers. It has 5 steps. Labels can be attached to containers when they are container can have multiple labels. Container can have multiple labels attached to them at any one. Notice in this example, because we are using the labels for use with the CLI and not single labels. To add single labels, you use option. The example below assigns a label called user with an ID to the container. This would allow us to query for all the containers running with a particular user. If you are adding multiple labels, then these can come from an external file. The file need to have a label on each line, and then those will be attached to the running container. This line creates 2 labels in the file, one for the user and the second assign a role. Step 2 is Docker image. Labeling images work in the same way containers but are set in the Docker file when the image is built. When a container has launched, the labels of the image will be applied to container instance. Single label within a Docker file, you can assign label. See the label instruction below. The label vendors is created with scrapbook. Third step is inspect. Labels and metadata are only useful if you can view querying them later. The first approach to viewing all the labels for a particular container or image is by using Docker inspect. The environment has created a container named by providing the running containers friendly name or hash. Using the if options, you can find JSON response to just the label section we are interested in. Image. Inserting images works in the same way, however, the JSON format is slightly different, naming it containing. These labels will remain if the image has been query by label. While inspecting dress and images provides you with more context on a production running potentially thousands of containers. It's useful to limit the responses to the containers you are interested in. Filtering containers. The Docker ps command allows you to specify a filter based on label name and value. For example, the query below will return all the containers which have user label key with the value katakoda. Filterable filtering images. The same filter approach can be applied to images based on the labels used when the image was built. When querying, both the label key name and value are case sensitive. This is why it is going to follow a consistent patterns and the recommended guidelines. Uh, the fifth step is daemon labels. Labels are not only applied to images and containers, but also the Docker daemon itself. When you launch an instance of the daemon, you can assign it label to help identify how it should be used. For example, it is a development to a production server, or it is more suited to a particular role, such running databases. We'll explore more about customizing Docker's configuration and how labels are used in future scenario, but as latest is below. In this scenario, we explored how you can use label to assign metadata to your Docker containers and images. This metadata can provide additional context around the individual items. Or use with filter to find the information you are looking for. In this tutorial katakoda practical series, uh, the 14th one is load balancing containers. Now I'm going to start this scenario. In this session, we'll explore how you can use in this session, we'll explore how you can use Nginx web server to load balance request between two containers running on the host. With Docker, there are two main ways for containers to communicate with each other. The first is via links, which configure the container with the environment variables and host entry allowing them to communicate. The second is using service discovery pattern where use information provided by third parties in the scenario when the service where the application use third party system define the location of, for example, if our application wanted to talk to a database, it would first ask an API what the IP address of the database is. This pattern allows you to quickly scale your architectures with improved fault tolerance than fixed locations. The machine named Docker is running on is called Docker. If you want to access any of the service, then use Docker instead of localhost or this 0000 IP. Um, the first step is Nginx proxy. In this scenario, we want to have Nginx service running which can dynamically discover and update its load balance configuration when new containers are loaded. Thankfully, this has already been created and is called Nginx proxy. Nginx proxy accepts HTTP request and proxies the request to the appropriate container based on the request host name. This is transparent to the user with happen without any additional performance overhead. There are three keys properties required to be configured when launching the proxy container. The first is binding the container to port 80 on the host using this. This ensures all HTTP requests are handled by the proxy. The second is mount the Docker stock file. This is a connection to the Docker daemon running on the host and allows containers to access its metadata via the API. Nginx proxy uses this to listen for event and then updates the Nginx configuration based on the container IP address. Mounting file works in the same way as directories using -v. And finally, we can set uh, an optional if a request comes in and doesn't make any specified host in this the container where the request will be handled. This multiple websites with different domains on single machine with a fallback to no website. You can make requests to the web server using this command. As we have containers, it will return 503 error. Here it is. Single host. Step 2 is a single host. Nginx proxy is now listening to events which Docker raise on start stop sample website called katakoda Docker which allows us to test that our proxy is working as expected. Internally, it's PHP and Apache 2 applications listening on the port 80. Starting container. For Nginx proxy to start sending requests to the container, you need to specify the to environment variable. This variable defines the domain where request will come from and should be handled by the container. In this scenario, we'll set our host to match our default host, so it will accept all requests. Testing. Sometimes it takes a few seconds for Nginx to reload. But if we execute a request to our proxy using this step 3 is last, we now have successfully created a container to handle our HTTP request. If we launch a second container with the same virtual host, then Nginx proxy will configure the system in a round robin load balanced scenario. This means that the first request will go container, the second request to a second container, and then repeat in a circle. There's no limit to number of nodes you can have running. Uh, just second container using the same command as we did before. Testing. If we execute request to our proxy using this command, then the request will be handled by our first container. A second HTTP request will return a different machine name, means it was dealt with by our second container. Let's see. Mm, in here, the host name is different. Then the fourth step is generated Nginx configuration. While Nginx proxy automatically creates and configures Nginx for us. If you are interested in what the final configuration looks like, then you can output the complete config file with docker exec as shown in below. Additional information about when it reloads the configuration can be found in the logos using Docker logos engines. In this scenario, we introduced how you can use Nginx proxy to dynamically load balance requests between two containers. The containers to handle each request is discovery using Docker API and is triggered when new containers are started or stopped. This pattern allows us to quickly add additional nodes to serve single website or use the same server to run multiple different websites. That's the end of our 14th scenario. That is the end of load balancing containers practical.